All right, so today we're going to look at Unit 10.4, Graphs of Polynomial Functions. This is going to be our second day of it. So some of this is going to be a review of what we've done the day before, but our real focus today is going to be to sketch the graphs as accurately as possible. We really just did general graphs on the previous day and analyzing those graphs, and today we're going to move towards making them as accurate as possible using the information that we know. So remember from before, we talked about the end behavior of graphs, right? What happens at either end of them? Are they going up? Are they going down? Are they going the same direction or opposite directions? So remember that we need to look at our highest exponent. If our highest exponent is even, right, 2, 4, 6, so on and so forth. So if we have an even one, we need to remember that both ends go in the same direction. Both ends go in the same direction. So for example, it might look something like this, where both of the ends end up going up. Now we need to decide, how do I know if both ends go up, and how do I know if both ends go down? The way that we decide whether they go up and down is by looking at the lead coefficient, right? So if we have a positive lead coefficient, that means that both ends will go up. Both ends up. If, on the other hand, we have a negative lead coefficient, then that tells me that both ends will go down. So when I look at these graphs, I know that their highest exponent was even because both ends go in the same direction. I know that this had a positive lead coefficient and this one had a negative lead coefficient because these both ended up going up and these both end going down. Now when we look at, so that was all about the even exponents, right? All of this was about even exponents. When we look forward to the next one, we'll talk about the highest exponent being odd, right? So like 1, 3, 7, right? Skipped 5, but yeah. Okay, so when we talk about odd ones, it's a little bit different. When we talked about evened, both ends went in the same direction. When we talk about odd, on the other hand, each ends in an opposite direction. Okay, so odds are going to end in the opposite direction. So it might look something like this, or something like that. Okay, now we have to decide which one of these, when will it end looking like this, when will it end looking like this, and that's based on the lead coefficient. Okay, so when we're talking about these, if it's a positive lead coefficient, then what I really think about it as it should be similar to a positive slope. Right? When we think about a positive slope, it goes up as you go to the right. It goes up as you go to the right. So when I look at these, as I move to the right, this one in general is going down, but this one is going up as I go to the right. So I know this one had a positive lead coefficient. If you have a negative lead coefficient, then that's similar to a negative slope. In other words, it's going to go down as you move to the right. So this one, as I move to the right, you can see that it's heading overall in the downward direction. So this one would have a negative lead coefficient. So that's what we would start out with. Whenever you have to sketch a graph, you really should get an overall view in your head. Are they both ends going to go up or down, or is one end going to go in a different direction than the other? And then what should those ends do? Once you get an end behavior, then you can go ahead and get more specific when you're making your graphs. And you can look for finding the zeros. Specifically, you're going to find a y-intercept, and you're going to find an x-intercept. So when we're trying to find the y-intercept, I kind of like to remember this as the opposite thing is 0. So if I'm looking for a y-intercept, that means my x is 0. So all I need to do is substitute 0 in for x and then simplify. And this will tell you where the graph crosses the y-axis. Sorry, that'll tell you where the graph crosses the y-axis. On the other hand, when you're looking for the x-intercept, again, you put 0 in for the opposite thing. So in this one, y would be 0. Then you would substitute 0 for y, or in some cases, it's going to be for like the f of x, because remember, this is just a fancy way of saying y. And then you're going to have to solve it. But you have to realize you can solve it in many ways, right? You can use your graphing calculator, right, to find solutions. And then synthetic division. You could use factoring. Right? There's a lot of ways that you can find those zeros. It just depends on what the problem looks like. And remember, with these ones, you need to describe what happens at each x-intercept. Does it bounce or does it cross? So remember, if it's an even multiple, it will bounce. If it's an odd multiple, it will cross. Okay, now we're just going to head up to back to the top where I had those couple of examples. So for this one, right away, the first thing I should be talking about is what's happening with the end behaviors, right? So this has an even degree, which means ends go in the same direction. And when I look at my lead coefficient is a 5, and it's positive. So since I have a positive lead coefficient, both ends will go up. But with the next one, when I look at it, my degree is 3, right, which is odd. If it's an odd, my ends will go in opposite directions. And in this case, my lead coefficient is negative, and since it's negative, that means it'll be like a negative slope. So that means it will go down to the right. So you can get a lot from it just by glancing at those first pieces. But once you do that, you'll need to make sure you go back and you find your zeros. Also, after you've described the end behaviors, after you've found your zeros, your x and your y intercepts, and described them as bouncing or crossing, you're going to want to use your graphing calculator to find other key points, because we want to make this as accurate as possible. So we'll want to find our local maximums and minimums. Remember, that means we have to do that calc function and select the bounds and enter to find your final solutions. So just a reminder, so there are 3 big things here, well 4 actually. Describing the end behavior, finding the x-intercepts, finding the y-intercepts, and then finding local maximums and local minimums using your graphing calculator. All right, so let's do example 1 here. G of x is equal to x cubed minus x squared minus x plus 1. So the first thing that I'm going to deal with is the end behavior. All right, so since it's an odd, my highest exponent is odd, that means that it will go in opposite ends, opposite directions at the end. And now, because I also know that this is a positive lead coefficient, because it would be a positive one, that tells me that it should be basically like a positive slope. In other words, it will go up as you go to the right. So that tells me over here that I'll be starting somewhere down here and ending somewhere up here. And now we have to figure out, okay, well, if it ends over here and ends over here, then what happens in the middle? So that's where the x and y-intercepts come into play. So let's start out with our y-intercept first, because I think that one's going to be the easiest. So we did our end behavior. We're going to do our y-intercept first. Remembering that when we do a y-intercept, that really means that x equals 0. So I'm just going to take this 0 and plug it in for x in each of the x spots in the equation. So I know, well, g of x is a fancy way of saying y, equals, instead of x, I'm going to put 0 cubed, minus, instead of x, 0 squared, minus, instead of x, 0 plus 1. Now, I could type this whole thing in my calculator to get the answer, or I can tell you 0 cubed is 0, 0 squared is 0, and this is 0. So we have all these zeros together plus 1, means that y equals 1. So my y-intercept is at 0, comma 1. And since it's a y-intercept, it will automatically go ahead and cross at that point. So I know at where x is 0, y is 1. This is a point, and it's going to cross there. So now that I found my y-intercepts, I also need to go back and find my x-intercepts. My x-intercepts happen where y equals 0. And this is really what we've considered throughout this unit to be the zeros of the equation, or the solutions, or the roots. We've called it lots of things. So that x-intercept is all of those things. So we would put 0 in for g of x equals x cubed minus x squared minus x plus 1. Now, I could go ahead and type this in my calculator and try to find the zeros, but this is actually one that we can solve by grouping. So I can group my first two together and my last two together. My GCF here is x squared, x minus 1. GCF here is not just x, it's negative x because of that minus sign, which would give me x minus 1. Since the binomials match, we know that this factored correctly. So now I have, ooh, that wasn't an x, that should have been a GCF of negative 1. I apologize, because negative 1 times x is negative x, and negative 1 times negative 1 is positive 1. So this is x squared minus 1 is one of my factors, x minus 1 is the other. And then we can set each equal to 0 and solve. So this one tells me x equals positive 1. This one would become x plus 1, x minus 1. So then I get x equals negative 1 and x equals positive 1. So when I'm looking at this, I know that my x equals 1 happens twice. So I have a point of x is 1, y is 0, with a multiplicity of 2. Now remember from before, if our multiplicity is even, that means it doesn't actually cross the x-axis. This bounces. My other x-intercept is negative 1 comma 0. It has a multiplicity of 1 since it only occurred once, so that means it should cross the x-axis there. All right, so these are the key points that I have so far on my graph. So now I can go to where x is 1, y is 0, and I know it's going to bounce. So this is going to go something like this. Then I can go to where x equals negative 1 comma 0, which means this is going to come back down and do something like that. Then I would go to my graphing calculator to go ahead and check this. So we're going to go to our y equals, clear that out. So we have x to the third minus x squared minus x plus 1. Then we're going to go ahead and graph it. So mine doesn't quite look like that because when I look at this here, do you see how we have a maximum that happens over here? My maximum is not at this point. So that's why you have to be careful. I really should not have graphed that right away because there's a local maximum here that I'm going to need to find. So right now, I'm going to use my graphing calculator and I'm going to find the local maximum that I hadn't already. So my maximum's over here, so we'll go to that calculator. Go to max. Remember, I think that's my highest point, so I'm going to go to the left of it, press enter. I'm going to go to the right of it, press enter. Enter again, and it tells me I have a maximum at negative 0.3 repeating would be negative 1/3, but it'd be okay if you wrote the decimal, and 1.19. So I'm going to need to go ahead and go to my graph. So negative 1/3 would be here. 1.19 would be here. So I got really close, but I need it to make an adjustment. So make sure as you do these problems that you're using an eraser, because you might need to erase and go back in and say, oh, this is really where that's happening. So it looks more like that. And then I've got all of my key information in here. I've described my end behavior, my y-intercept, my x-intercept, and I described what happened at each point, and I gave a local max. So we're going to do one more together. Okay, we're going to do one more together, but we'll start that on the next video.